Sometimes with a quadratic equation, you can solve it simply by taking the square root. Now you can only do this in certain situations, not with any quadratic equation, but we're going to talk about the type of quadratic equation where you can do that. Now a few things before we get started on actually solving equations. So first of all, a radical is an expression that has a square root symbol. So anything that has a square root, we call that a radical. Now the number underneath the radical is called the radicand. Now I'll typically probably refer to it as just the number under the radical, but that is the official name for it. Now there's a couple of properties of radicals I want to remind you of. So if you have the square root of two numbers multiplied together underneath a square root, you can break that apart into two separate square roots. So for example, 18 can be written as 9 times 2, so we could rewrite that as, instead of 18, just 9 times 2 underneath the square root. And then we can break that apart into two different square roots. Well, 9, you can take the square root of that, so then we could just turn this into 3 times the square root of 2, because the square root of 9 is 3. So I like to think of square roots as like a question. So this is saying, what number multiplied by itself gives you 9? Well, 3 multiplied by itself gives you 9, so the square root of 9 is 3. The other thing I'd like to remind you of is that you can do the same thing with division. So since multiplication and division are really the exact same operation, just with going the opposite direction, all the same rules apply. So you can also split apart division over a radical as well. So we could do something like 2 over 25, if we're taking the square root of that. Could turn that into the square root of 2 divided by the square root of 25. Well, the square root of 25, that's the number you'd have to multiply by itself to get 25. So that is 5. One more thing I want to remind you of is that numbers have two square roots. So if we look at a number like 9, there are two square roots of 9. One square root is a positive and one is a negative. So the reason is that 3 squared is 9, but also negative 3 squared is 9 as well. So that's negative 3 times negative 3. Negative times a negative is a positive. All right. The symbol, though, if we look at this actual symbol, this thing itself, that has a very specific meaning. That means the principal square root, which means the positive square root. So if you have something like the square root of 25, like we had over to the left, that is actually just equal to 5. So that specific symbol means the principal square root. It means only the positive version of that root. So when we're solving an equation, we should get two answers. So actually, let's look at the first example. X squared equals 169. Well, 13 squared is 169, but also negative 13 squared is 169. So we should, when we solve this, get positive or negative 13, because both of those will make that equation true. So remember, when we're looking for solutions to an equation, we're looking for numbers that we can plug into that equation that make it true. So for the first example there, if we plug in negative 13, we will get equally as true a statement as if we plug in positive 13. So those are both solutions to the equation. So there's some funky business with trying to work this out in the mathematically correct way with using this symbol that means just the positive square root, and then also something like this. So let's take a look at the square root of x squared. Now, I see a lot of students saying that the square root of x squared is just x. And it seems like that should be true, right? Because if you square something and then take the square root, you get back to where you started. So like if we take 5 and then square it, we get 25. If we then take the square root of 25, we get back to 5. So it seems like that should just be x. But in fact, it's not. And the reason is that x is an unknown, so we don't know what x is. So think of it this way. If I tell you I square a number, and when I square that number, I get 16. What was my original number? So you might be thinking, well, 4, because 4 squared is 16. But it could have just as easily been negative 4. So if I tell you, again, we start with, I say, I have a number in my head, I square that number, and when I square it, I get 16, and I ask you what the original number was, there's no way you can tell whether it was 4 or negative 4. It could have been either one. You couldn't tell unless you were to ask me. So another way to think about that is if we take, so say we take something like negative 4 squared and then take the square root of that. Well, what we would get is negative 4 squared is positive 16, so that's the square root of positive 16. Well, that's the principal square root, so that is 4. Okay, well, but the original thing we plugged in was negative 4. We go through and do this math, and then we get positive 4. Well, think about what function turns negative numbers into positive numbers. Well, that's the absolute value. And so the square root of x squared is actually the absolute value of x. And again, if you think about that, that makes sense, because anytime you square a negative number, you get a positive number. So if we have x squared in here, that's going to take any numbers that are negative and turn them into positive numbers when we square them. And then we take the principal square root, and then we get a positive answer. But that positive answer could have come from a negative beginning. So we got to have the absolute value here. So when we solve equations then, what we want to do is we want to take the square root of both sides. So if we're trying to get rid of x squared, we need to take the square root to get rid of x squared. So what that means then is we have the absolute value of x on the left side, because the square root of x squared is going to be x, except we could have had a positive or a negative answer there. Then the principal square root of 169 is 13. So we get the absolute value of x equals 13. Well, then we got to think back to how to solve absolute value equations. So if the absolute value of x is 13, well, what that means then is that x could have been either positive 13 or negative 13. So we have one equation where x is positive 13, one equation where x is negative 13, and then we would solve both of those equations, although in this case they're already solved, so we don't have to worry about that. So we get two answers here. All right, for the second one, again, square root both sides. We get the absolute value of x equals square root of 50. Well, that means that we're going to have either x equals positive square root of 50 or x equals negative square root of 50. All right, but I actually want you to leave your answers reduced. So we're going to reduce this radical. If you don't remember how to do that, there's kind of two ways of doing it, so I'll show you one with each of these. So the first way to do it is if we look at breaking this apart into a factor tree. So we look at all the ways that we could kind of split this apart. The one that comes to mind here is 2 times 25, but it doesn't matter how you split it up. And then we would do, let's see, 25, the only way to split that is 5 times 5. So what we've really said here, once we get to the end of the branches, is that 2 times 5 times 5 is 50, which is true. 2 times 5 times 5 is 50. So this 5 and 5 here, this is really 5 times 5, which is 5 squared. And so we can take the square root of that. And when we take the square root of that, we get 5. So the square root of 5 squared is 5. Or the square root of 25, you can think of it that way too. And then anything that's left over isn't multiplied by something else like itself, so it's going to stay underneath the radical. And so we get 5 times the square root of 2. Now the other way that we can do this is just like at the beginning of the lesson, we can break it apart. So there is a perfect square inside of 50. So that means we could split this apart into the square root of 25 times the square root of 2. Because the square root of 25 times the square root of 2 is the square root of 50. And then we can take the square root of 25, and we get 5. And then the square root of 2 can't do anything with that. And so we get one answer that's positive, one answer that's negative. Now, if you want to, I have no problem with you writing it like this. If you want to just write both answers, 5. 5 square root of 2. If you want to write both answers at the same time, just use the plus or minus symbol. That's just fine. No problems there. All right, let's look at the next example. 3x squared plus 5 equals 41. So when we're solving an equation like this one, we've got a few steps to take first. Well, basically what we want to do is pretend that this is not x squared first. So we'll just ignore that. Pretend you just have 3x plus 5. Solve that equation like you normally would. So we're going to subtract 5 from both sides, and we get 3x squared. But again, just pretend that that's regular x for now. So we want to solve for regular x. All right, so then 41 minus 5 is 36. Divide both sides by 3, and we get x squared equals 12. And then we want to take the square root of both sides. On the left side, we get the absolute value of x equals, and then the square root of 12, but we want to reduce that. We can reduce that. So actually, before we reduce that, let's just turn this into x equals plus or minus square root of 12. Now, since we've done a couple of these now, I will tell you I'm totally fine with you guys taking a shortcut and skipping over this absolute value step. If you just want to skip straight from here over to here, and just say, okay, when you take the square root when you're solving an equation, you're going to get a plus or minus. If you just want to skip over that absolute value step, I have no problem with that. All right, now let's reduce this radical. So it seems to me that most of you guys prefer the factor tree, so let's do that. So we could split this into, say, 2 and 6, which can be split into 2 and 3. Look for pairs. Again, because what this is really saying is that 2 times 2 times 3 is 12, which is true. So this 2 and 2, this is really 2 times 2, or 2 squared. So since that's under a square root, we can take the square root of that, which is just 2. And then the 3 is all by itself, nothing to come out with. So that's going to stay underneath the radical. And then we have plus or minus, so we get x equals plus or minus 2 square root of 3. So two things before I move on. First of all, when you're solving equations like this, especially on a quiz or test, make absolutely sure that you have both the positive and the negative answer. I will mark it wrong on a test if you only give me the positive answer, because you've only given me half of the answer. The negative answer is exactly as legitimate as the positive answer, so don't leave that out. I will take off on tests if you don't give me both answers. And also make sure you're reducing every radical that you can. That's another area where on this test I see a lot of students losing a lot of points because they don't reduce radicals and they only give me one of the two answers. So make sure you get both of those so you can get full points on the test. All right, 2 more equations and then we're done. So again, when we're solving an equation like this, what we want to do is try to get the x squared by itself. So just solve that as if it's just regular x instead of x squared. Go through and solve it exactly the same way, and then at the end, take the square root. So let's add 6 to both sides, and we get x squared over 25 equals 4. Well, the next thing that we would want to do here is multiply both sides by 25. Since we've got x squared divided by 25, to undo division, we're going to want to multiply. So that would be, let's see, 25 on this side and then times 25 on this side. That's going to leave x squared on the left side. 4 times 25 is 100. Now we want to get rid of that x squared, so let's take the square root. Remember that we're always going to have the plus or minus. So I skipped that absolute value step here, which again is just fine with me, as long as you remember that you need to have the plus or minus, because there are 2 solutions here. And then the square root of 100 is 10. Now let's look at something like this last one. All right, so what we're trying to do is get this part that has the squared all by itself. We want to get that by itself first. So actually a very common mistake that I see with students is they want to try to square that. And actually first, before we even go on for that, I want to try to preemptively correct a very common mistake that I see. I see a lot of students saying that this is going to be, the same thing as 7 times x squared minus 16. That is absolutely wrong, badly wrong. So do not ever do that. This is very wrong. Remember that when you square something, remember what that means. It means you're multiplying it by itself. So if you were to do that, you would have to do this and then FOIL. That is how you would multiply that out if you were multiplying that out. But we're not even going to do that because if you were to multiply this out, then you would get something with x squared, but then you'd also get something that has an x in it. And we can't solve an equation like that if it's got both an x squared and an x. We can't solve that by taking the square root. So we do not want to multiply this out at all, even. Even if you do multiply it correctly, that's not what we want to do here. What we do want to do here is take this part that is being squared and then we can take the square root of that. All right, so we'll add 18 to both sides first. So just pretend that that box there is x. So we want to solve for that box, that red box. Okay, so then we have 7 times the red box squared equals, then 10 plus 18 is 28. Then again, we're solving for that red box, so we'll divide by 7. And so we get the red box squared equals 28 divided by 7 is 4. So now I guess we can fill in that red box. All right, now we've got that red box by itself. So what we want to do is take the square root to get rid of that squared. Take the square root of both sides, and then what we end up with is x minus 4. So if you have x minus 4 squared, and then you take the square root of that, you're left with just whatever is inside there. So you're left with just x minus 4. And then we have the plus or minus. Again, I could have done the absolute value of x minus 4 equals 4, but we'll skip over that absolute value step and just go straight to saying we've got plus or minus 4 there. And now we want to solve this. So the best way to solve this, I think, is to just remember that there's really 2 different equations packed into this. So we've got one equation where x minus 4 is equal to positive 4, and another equation where x minus 4 is equal to negative 4. And then we can solve both of these equations. So here we're going to add 4 to both sides, and we get x equals 8, so that's one of the solutions. Here we're going to also add 4 to both sides, but this time we're combining negative 4 and 4, so that gives us 0. So the 2 answers to this equation are 8